All right, this is Algebra 1. Happy Halloween, 2-9. Number of solutions. This is the harder version of this. Again, 2-8 was yesterday. That was just number of solutions intro. So let's go ahead and talk about how you can get certain types of solutions. So if the variables, the left and so this is assuming that the both sides of the equation have been simplified. So after you simplify both sides of the equation, if the variables on the left look like the variables on the right, and something happens with the constants as well, that will be either infinite solutions, one solution, or no solutions. So let's go ahead and write here, we'll make the constants left equal right as well. I want to write in blue here. Left is equal to right. And if you can't picture what that looks like, it's something that looks like this. And I can do a mini example out here just in case you need it. It's something like x plus 1 is equal to x plus 1. The variables are x and x. The left is equal to the right. I have x and x. The constants, the left is also equal to the right. The 1 is equal to the 1. Again, constant is a fancy word for number. So when x plus 1 is equal to x plus 1, what is that? Is that infinite solutions, no solutions, one solution, quiet raised hand? The variables left equals right, constants equal left equal right. This equation right here. Infinite solutions, one solution, no solutions, raise your hand. Only 2 people know. For this equation right here, how many solutions? Only 2 people know. 3 people know. 4 or 5 people know. Andres? Infinite solutions. There it is. Grab your candy, get XP. Infinite solutions. So I'm trying to show us the shortcut now so you can immediately jump to how many solutions there are just knowing what the equation looks like. All right. So let's go ahead and say variables left equals right again. The left is equal to the right. So in my new equation over here, I have x is equal to x, but I don't know what's happening with the numbers. Now I'm going to say for the constant, the left does not equal the right. The way that I say that is the left, and I'm going to do red here so you can see the difference, does not equal the right. The left does not equal the right. So our example over here would be x plus 1, x plus 2. Now the constants are not the same on the left and right. I have 1 on the left, I have 2 on the right. So the variables are still the same, but now the constants are not. Now my question for you with the quiet raised hand is, how many solutions do we have? How's it going? Oh, yes. How many solutions? Monse knows. Jose knows. Only 2 people know. 3, 4 people know. Monse, go for it. No solutions. There it is. You may grab your candy whenever you are ready, Monse. And there's your 50 XP as well. All right. And this is going to be for XP as well. How can I get, I know that the last one is going to be one solution. But now what do I need to write here for the variables? Should it be left equals right? Should it be something else? What should I be writing in order to only get one solution? And maybe you need to think back to our warm-up. That's the wrong warm-up. This is for Algebra 1. Remember that this one had one solution. What was happening with the variables for both sides of this one? Did the left equal the right for those variables? So think back to the warm-up. What do you think? What should I be writing here? Does the left equal to the right? Quiet raised hand if you have an idea. By the way, you can still make an incorrect guess and you still get candy. So, Fernando, go for it. I should write no here, or?
Wait, left equals right, and then cross out the equals.
So left does not equal right.
Yeah.
You are correct. Go ahead and get your candy. Let me come back over here, Fernando. 50 XP. Yeah, so the left cannot equal to the right. And you can see that in our example. So over here on the left, we had 17z. Over here on the right, we had 4z. The variables did not match up. This one was not the same as this one. The left was not the same as the right. So on our example for our notes, we can say something like this. 2x is equal to 3x, or something like that. The variables are not equal to each other. And maybe I can make that even clearer by grabbing, I wonder if I can, maybe not, okay. Well, I would like to change that to red, but I can't grab that. All right, and then we don't really care what happens with the variables. For example, I could just leave this, and I don't even need the same variables. I could have the same variables on the left and right, or I could have different variables. It doesn't matter. So you can just, in our example, say box for the variable, box for the variable. It doesn't matter. It doesn't matter. As long as the left does not equal to the right in terms of the variables, you will always have one solution. You can choose whatever you want for the constants. You can choose 1 and 2, you can choose 2 and 2, you can choose 100 and 300. It doesn't matter what the variables are. As long as the left variables and the right variables are not the same, you're always going to have one solution. So now you have a shortcut for the homework that was due today, but now we need to apply these tricks on our new examples. Which values of P and Q, so I'm going to choose something that goes in for Q, something that goes in for P. What values go in for P and Q to make this equation have infinitely many solutions? And if you don't like this word infinitely, you can draw this symbol underneath. Infinitely is that same infinity sign. How can we have infinitely many solutions to this equation by plugging in a value of P and Q? So I'm going to go ahead and write this right now. I know I'm going to be searching for something for P. I know I'm going to need something for Q. What do I plug in there? And you're going to use this shortcut table above us. I need infinitely many solutions. So right now I am in this row. Infinitely many solutions. What am I going to choose for P and Q? So let's start with P. What should I plug in for P? And I'm talking about the x's. So I'm looking at this x, and I'm doing something to them. What should I plug in for P? I see one hand. I see two hands. I see three hands. Cohen, go for it. 37. Why? Yeah, so the left needs to equal the right. For the variables, this is the variable x's. 37 needs to be equal to 37 in order to have infinitely many solutions. So you're going to go ahead and grab your candy. Thank you. All right. What should the value of q be? And again, q is now a constant because there's no x next to it. I see 3 people have hands, 4 people have hands, 5 people have hands. Gunnar, go for it. 13, there it is. Good job, Gunnar. Go ahead and grab your candy. Q needs to be 13 because both the variables and the constants need to be equal to each other. All right. Are there any questions on example 1 before we go to example 2? I'm going to give you less hints, and I'm just going to ask for P and Q, and you guys are going to have to get it. No questions? No questions? All right. We're going to the next one. Example 2. Which values of P and Q result in an equation with no solutions? So no solutions. That means I'm coming back up here. I'm looking at this second row. No solutions. Okay. So I need a value of P. I'm going to write that down. I need a value for Q. Write that down. What should they be? I want a quiet raised hand for P, and then after that, I'm going to call on a quiet raised hand for Q. What should P be in order for me to get no solutions? I see Gunnar has his hand raised. I prefer on calling on someone new so more people can get candy, but I can call on people that have already participated to get the XP. I still only see Gunnar's hand. What should P be? No one else has a hand? All right, go for it, Gunnar. 3. Why'd you choose 3?
Because that's random, and there's a 3 right there, so
Yeah, so P is a constant. There's no x next to it. And what do we know about constants for no solutions? The left cannot equal the right, so I have to choose a number other than 100. Well, 3 is a number other than 100, and he saw 3 there, so that's why he chose it. You're correct. Good job, Gunnar. All right, what about a value of q? What value of q should I choose? Gunnar's all ready to go. I see people with their hands raised. Anyone else? Anyone else? Jose?
-3.
-3. Why -3?
Because if you add 3x on both sides, they don't cancel out each other.
Yeah, exactly. So they will go away and I'll have a number over here equal to a different number. I need the same variable, this same -3 here and here. Yeah, and you haven't got candy, right? Go ahead and grab some. All right, in our third and final example, there's only 2 more people that can get candy unless you help your peer on the homework. I need a value of p. I need a value of q. Who's going to get some candy? Who's going to get some XP? I need this equation to have exactly one solution. Exactly one solution. So I'm looking at this row right here. All right, be thinking about this one. What value of p and q will work? All right, quiet raised hand for P. Gunner's ready. Hopefully someone new. I might have to cold call on people to force you to take candy from us. I want new people. So while I can call on Gunner, I apologize, Gunner. But thank you for participating so much. You really know this material. You want to try Eder? Go for it, Eder. P.
-67.
-67, like that?
Yeah.
Why'd you choose -67?
So what's that?
So cancel?
Yeah.
Cancel with which one? With the 45? Or with the 67?
67.
All right. So you are actually correct that this value will give you exactly one solution, but your reasoning is wrong. So I'm still going to give you your XP because you have the correct answer. So you can go ahead and grab your candy, or someone can slide the candy over to you. Oh, swirly chair, or the rolly chair. Yeah. So -67 will work because I'm looking at this variable, or this term with a variable, this term with a variable. I need to choose a number other than 45. A number other than 45 is -67. I could have chosen 1. I could have chosen 100. I could have chosen pi. Any number aside from 45 here will work because in here I say the left cannot equal the right for the variables. So any number aside from 45, and maybe you want to add that to your notes too. Any number, I don't know what I was writing there, aside from 45 would have worked. Let me erase that guy and this guy. All right. And our last volunteer for our notes, what should my value of Q be? Anyone at all? And you're looking at the table. For the constants, again, Q is a constant. It's by itself. There's no variable next to it. For the constants, it doesn't matter. It doesn't matter. So give me a value of Q. I'm going to cold call on someone unless someone new raises their hand. All right, Jessica. What's the value of Q that I can plug in? Yes, Gunnar, you have it right. It is 25. Any number would have worked because it doesn't matter. I don't care what constant you choose. It doesn't matter which one. It could have been 25. It could have been pi. It could have been -67. It doesn't matter. So 25 works. So Jessica, you can grab some candy. Thank you, Gunnar, for helping her out. Yeah, and again, any number would have worked. Any number works. And I do want to add on to our notes just a little bit up here. In terms of the no solutions, this one had to be -3. But for the value of p, this one could have been any number but 100. Just add that onto your notes and we're good. So I added on to example 2 notes. There's example 3. Any questions about example 1, 2, or 3? Because the homework is going to look almost exactly like these examples. Questions, questions, questions? All right, that concludes the notes. Go ahead and write your summaries.